So now that we've determined how to create the sample space or determine how many ways an event can occur, listing them all out, we need to be able to count them. So the fundamental counting principle tells you how many ways can something occur. So the table in the tree gave us what occurs. The counting principle tells us how many things can occur. And truly what we want when we're doing probabilities usually is using the counting principle to determine how many things can occur. So go back to that tree that we created about the computer. We had a choice of 2 choices for the RAM size, 3 choices for the screen, and 2 different application packages. Once we did out the tree, we determined that there were 12 total things. So is there an easier way to determine the number 12 without having to draw that tree every time? And the answer is yes, the fundamental counting principle. What the counting principle does is you determine how many choices you're making. For instance, on the computer problem, we were making 3 choices: RAM size, screen size, and application package. You take how many options can you do each one of those things. We had 2 for RAM size, 3 for screen size, and 2 for application packages. And the counting principle says multiply each one of those numbers together. 2 times 3 times 2 is 12, which was the total number. Think about the die problem that we had. The first die that we rolled was a green die. The second die that we rolled was a red die. There were 6 options for each, so 6 times 6 gave us the 36, which is the total number of possible. Again, the counting principle tells you how many, but it doesn't tell you what the actual outcomes are. So, if you read the counting principle, it says, let E be a multi-stage experiment. N1, N2, N3, all the way through K are the number of possible outcomes of each stage. Then what it tells you to do is multiply those numbers together. So let's look at example 9 together. It says, in horse racing, betting on a trifecta refers to choosing the exact order of the first 3 horses across the finish line. If there are 8 horses in a race, how many trifectas are possible, assuming there are no ties? So again, a trifecta, we are picking the first 3 blanks, the first 3 places. We have first place, second place, and third place that we have to choose from, that we have to fill in. When we pick our first place, how many options do we have? Well, since there's 8 horses can come in first place. Now that first place has come in, how many horses are left? Well, now there are 7 distinct horses left that could earn second place. After the first 2 horses have come in, there's 6 distinct horses that could come into third place. And then the fundamental counting principle says what we do is we multiply these numbers together. You will be using a calculator nonstop, so get comfortable with it. It seems to me that 8 times 7 times 6 is 336 total possible outcomes. So that's where I'm getting my number 336 from. Let's read example 10. It says 9 runners are entered in a 100-meter dash for which a gold, silver, and bronze gold will be awarded for first, second, and third places, respectively. And how many possible ways can the medals be awarded? Again, here we think about what choices are we making. Well, we're making a first place, second place, and a third place choice. That's gold, silver, and bronze. It seems that we look at how many people actually ran it. It says 9 runners. So how many choices or how many people do I have for first place would be 9, for second would be 8, and for third would be 7. The fundamental counting principle says multiply these numbers together. Using your calculator, 9 times 8 times 7, I get 504 total possibilities.